Well, welcome to MV Tutors. If you'd like a session after this, comment and ask for one, or alternatively, you can visit our website and book a session through there. The website is found under the description of this video. Okay, well, today we're doing functions and inverses, which is going to talk about functions and see what we can learn about them. First of all, I like to start with a vision. So this is the vision that we're looking at right here. This is a question that we need to answer at the end. It's a past exam paper. If you don't know how to answer this question, then stick around and find out what you need to know. Okay, let's get right into it. Let's get down with the theory of it. Okay, so we'll be talking about functions. Okay, so we'll talk about the basic functions, the common functions that we are used, especially in matric grade 12. The first one is a line function. Okay, let me just switch to a pencil. Okay. Okay. Okay, now this is a line function where you just have a line. Let's say that's the line. Okay. Cool. And then we have x here and then we have y there. All right. So let's go back to our pen. So the basic equation for this line is just y is equals to, do you know it? No, you don't. It's mx plus c. Okay, so this is what we call a straight line, or let's just call it a line. Okay, that's it. And then another common one that we do have is this one which we call a parabola. Okay, let's just get this function, straight line. There's this one that we call a parabola. It's basically like this. Okay. So that one is what we call a parabola, and it's given by the formula y is equals to ax squared plus bx plus c. Okay, letters are just constants. They can be numbers, it can be 1, 0, 3, whatever, the letters. But the important part is that it's squared. Now this is what we call a parabola. Okay, and then another function that's fairly common is this one, which we call a cubic function. Okay, so you can have a cubic function like this. Okay, so this one is what we call a cubic function. And it's given by the formula y is equals to ax cubed plus bx squared plus cx plus d. Okay, that's it. And then the next one that we need to discuss is this function, which is called, let's just draw it first. Oh, okay, so make sure it's straight line. There we go. And then put a straight one here. Okay, so this one is called an exponential function. It has an asymptote. An asymptote, it gets close to it. The asymptote here is the x. axis. It gets close to it, but it never touches it. Okay, but we're not there today. We're just discussing functions. Okay, so the formula for this one is equals to y is equals to ax. That's the exponent there, when x is an exponent, not a. So this one is called an exponential function. Okay, we need to know that one. And then that's our next one that we need to know. Let's just get our pencil ready. Okay, so let's draw a line. Okay, now instead of crossing the y-axis, this one crosses the x-axis. Okay, so this one is what we call a logarithm, a log graph, or a logarithmic graph. I'm just gonna call it a log graph for simplicity. And the formula is y is equals to log a as a base and x right there. Okay, now you can see that there must be a relationship between exponential and the log graph, because this one crosses the x, but it also has an asymptote on the y, meaning it gets close to it, but it never touches it, whereas the exponential crosses the y-axis but gets close to the x and never touches it. Okay, now let's just get one more popular one. Okay, let's draw a line and another. Good. And then okay, so this is what we call a hyperbola. Okay, so and it's given by the formula y is equals to a over x minus p plus q. Okay, if you want to go over these, you can book a session with me. We'll go over them. It's okay. All right, so we're done with those. Those are the popular functions. Now, there's something I need us to talk about. Okay, is this thing that's called a vertical line test. Vertical line test. Now, vertical line test, it determines a function. Okay, if something is a function. And for something to be a function, it needs to cross once. Either you say cross once or cut once. Okay, it's cross once or cut once. So let's go ahead and apply a vertical line test. If it crosses the function once, then it is a function. Okay, let's start over here with the line. So if you draw a horizontal line, will it cut it once? Yes, so this is a function. Okay, this one, will it cut it once? If you draw a horizontal line, cuts it once, so a parabola is a function. This cubic one, if I draw an arbitrary vertical line, did I say horizontal? I meant vertical, sorry. So vertical because you can see I'm drawing vertical lines. So it crosses once, that's a function. Let's see, crosses once, that's a function. Crosses once, that's a function. Crosses once, that's a function as well. Okay, so all of these are functions. I want to talk about the horizontal line test, but now is not the time. We'll talk about it in a bit. Now, let's talk about inverse. Oh, sorry. Let me take this off. Inverse functions. Now, how do you make something an inverse function? First of all, you need to swap x and y. Where there's an x, you put a y. Where there's a y, you put an x. And then you make y subject of the formula. Okay. Also, what you need to know about inverse is that an inverse is actually a reflection by the line y is equals to x. Okay, so let's just go ahead and do those. We'll need to use a different color, so I'm thinking let's use orange. Okay, and let's use an orange pencil. All right, so remember we said it must be reflective by the xy line. So an xy line is over here, it crosses this path here, so it's really like this. That's our xy line. So if we put a mirror on our xy line, this line is going to be this side. Okay, I need it a little bit bigger, a little bit thicker. Okay, we'll use purple for the light, reflective line. If I put it this side, the line is going to be here. The purple line, this is the inverse. Okay, it's also a function, as you can see, crosses once. Now we do the same over here. If we put a reflective line by the xy, this graph is going to look something like this. Okay, if I put a mirror on the orange line, this graph is going to look like this. Okay, something like this, but it's going to be much more clearer if it was on the 0 point there, over there. So as you can see, the inverse of a parabola is not a function, because now if you apply the straight line like we did here, the straight line, let's just extend this one. If you apply a straight line over here, you can see it touches two places, 2 points. It touches over here, and also it touches over there. So it means the inverse of a parabola is not a function. Okay, it's not a function. Still applying the vertical line rule. Okay, let just get rid of that. Okay, so it's not a function, that's clear. Now the inverse of this as well, you would do the same. You would you'd still put a line over there and then try to, you know, get the inverse, but it's not so easy to draw this one, so you need to recalculate it literally by where there's an x. Let me just show you how to do that. Okay, where there's an x, you put a y. Where there's a y, you put an x. So you would put, looking at this this function here, this formula, where there's a y, you put an x, and then a y3 plus by squared plus cy plus d. This is the inverse. Okay, obviously you'd have to make y the subject of the formula. There are ways to do that, but this is not what we're discussing today. We're just discussing the functions. So you can book a session if you want to go further than this. Let's continue over here. So we're gonna apply our line here to inverse line. Okay, now if we apply our inverse line, as you can see, let me just rub that. If you apply, I'll put this line first, the XY line right there, and then you reflect this line. Okay, when you reflect that line, it comes right here like that. Okay, so as you can see that this line is actually the same as the log graph. This graph, that's an inverse. Okay, this one, that's an inverse. It's actually, it becomes a log graph. So that's the relationship I was talking about earlier, that is between the two of them. So there we go, there we have it. Okay, now same with this one. You would apply your line xy hyperbola. Doesn't change much, but that's it. Now we can talk about the horizontal. Not a pencil, man, I want a pen. Okay, so we are talking about now we can talk about the horizontal line test. Now this one, it actually determines if a function has an inverse that is also a function. Okay, so if we apply our horizontal line test, we draw a horizontal line and then we find out that it crosses it once, then the function also has a function that's an inverse, that's a function. Let me just go ahead and show it to you. Let's use a pencil again, but we need to let's use green this time to apply a horizontal test. Okay, so if we put a horizontal line here, it crosses, it touches, or it cuts once. So the inverse of this hyperbola is also a function. Okay, if we apply it here, cuts once, so the inverse is also a function. Likewise, cuts once, exponential, inverse is a function. Now here we go. if we apply it here, it cuts 1, 2, 3 times. So the inverse of this is not a function. Okay, so you see what I mean. Also, if I apply it on this one, a parabola, it cuts once, twice. So the inverse of this parabola is not a function. Now let's do the line, straight line. The inverse of this is a function because it cuts it only once. Okay. Now let's go ahead and do the question and see how exactly they ask these things in the past exam. Okay, so here we go. Now the graph of g of x is a to the power x. So what kind of function is this? It's an exponential function. Okay, it is shown in the sketch below. The point 2, 1 lies on g. T is the y-intercept of g. First question is, write down the coordinates of t. Okay, so man, let's go back to my red pen. Okay, so 5.1, the coordinates of t. Where is t? We can see t is there on the graph where x is 0. So we know, we've been told that g of x is equals to ax. Okay, that's like saying y is equals to a of x. So now what we can notice about t is that t is where the graph is actually 0. So where there's an x, we substitute 0. Okay, the x value is 0 there. Okay, so anything to the power of 0 is equals to 1. It doesn't matter what number this a is, any constant it is, it's always going to be equals to 1. So now we have the y coordinate. Therefore, t is therefore 0, because that represents x, and then y is represented by 1, so x1. So t is 0, 1. That's it. Calculate the value of a. Okay, so once again, 5.2, what do we know? We know the formula is y is equals to a to the power x. So what we need to do now is substitute. We need a point where this graph passes, and we've been given a point, it's 2 and 9. We are very sure the graph passes there. So we have 2 and 9. Now I like to put x on top and y on top just for simplicity's sake, so that when I come to substitute, I don't struggle. I can just see where there's y is 9 is equals to a, and then for x is 2. Okay, now I need to solve for a. Now if you know your mathematical gymnastics, how to solve exponents, you would know that you need to change the 9 into something that has a power of 2. Okay, so it just so happens that 3 to the power of 2 is equals to 9. So a to the power of 2. Therefore, since we have 2, 2, these also have to be the same. A is equals to 3. Okay. Now, let's move on to the next question. They say 5.3, the graph H is obtained by reflecting G in the y-axis. Write down the equation of H. Okay, so what they're telling us is that they basically they are reflecting g of x by the y-axis. So by the y-axis here, we're putting a mirror here. Okay, so we have a mirror here. When we have a mirror there, the graph that we are actually going to get, if you put a mirror there, it's going to be like this. Doesn't touch there. It pretends as if it's going to touch, but it never really does. Okay, crosses that one, and then there. Now if you look at this graph here, this graph is what we call, okay, let's just write 5.3. 5.3. So the question wants the equation of h. Now h is this graph here that we just drew. Okay, so if g of x is equals to a to the power x, then h is a to the power negative x. That's all. This is a negative, it's a negative exponential graph. It's drawn like this. Okay, if you don't understand that, again, just book a session with me and I'll be glad to tutor you and how that becomes. Okay, 5.4, write down the values of x for which we have that condition. So what's that condition? We have 0, it's less than, so a log 3x, 3 as a base, x there, and there's a 1 there. Okay, so basically they want to know for which values of x, very important, of x, means we need to have x here. Okay, so we're going to take it piece by piece. We're going to take this first one, we're going to say 0. Instead of this sign, we'll just put a equal sign. Okay, oh wait, let's just put the less than. Okay, and we have log 3x this side. So what we're going to do then is to make x the subject of the formula. And if you know how to convert a log into an exponent, you know that they have the same base. So 3 is the base, and then that 0 becomes the exponent, and this side I have an x. So remember, anything to the power of 0 is 1. So we have this condition. Okay, we'll do the same for this side. We're going to say log 3x is less than 1. Okay, so we'll do the same. Making x the subject of the formula, we know when you convert the bases are the same. So the base is 3, and then that 1 becomes an exponent. So this side we have x, 3 to the power 1 is still 3, and then therefore our final answer, then we have x, we put this side exactly as it is, we put that side exactly as it is. Done. Okay, thank you very much for watching this video. Please like and subscribe.